Hi, I'm Sierra Johnson. I'm an environmental engineer. I work primarily in drinking water treatment, and I want to talk to you today about an open source R package that we're developing for our water treatment plant models called Tidywater. So I want to go over a little bit why we needed these tools in the first place, some challenges that we ran into as we were actually writing the code, how we were able to kind of make the case for open source at our company, and then some of the challenges that we ran into in the approval process. So when I originally submitted this abstract, I really thought I was going to be sharing the actual package with you and you'd be able to go to these links, but there's always a few hiccups, and so we can talk about those. Conceptually, drinking water treatment, it's pretty straightforward. We have kind of different classes of contaminants in our waters. We have organic matter, which is naturally occurring and pretty complex structurally. We have kind of man-made contaminants, and then we have the pathogens. And treatment processes can be pretty varied, and they can deal with these things by a number of mechanisms to produce safe drinking water. And kind of where my job comes in is how do we choose the right treatment processes and how do we make sure that they are affordable and efficient? So I mentioned that we have a lot of processes. And so when we start trying to put everything together in models, there's a lot of variability. And so we have, some things such as disinfection or filtration are consistent across different processes, but everything else, there's just a lot of different permutations depending on somebody's source water quality. We do this modeling to answer a lot of different types of questions. So there's the optimization side of things, which is very much related to cost and kind of efficiency. Then there's the resiliency side of things, which is we need to know that we can continue to produce safe water when these unexpected events come up. And then there are things that we can plan for in the future, like changing source waters, changing treatment processes, and then future regulations. But our current modeling tools leave a little bit to be desired. So we collect a ton of data by kind of the nature of the industry. So the people running the plants have to take a lot of samples and measurements to make sure that they can effectively treat the water. Then there's the compliance side of things to make sure that the water is actually safe and meeting regulations. And those are separate groups usually in separate data sets. There are online analyzers that go in yet a different server. And then because kind of the chemistry is complex enough that you can't just apply things universally, we end up doing a lot of studies that are kind of one-off and specific to utility. And so we get even more data that lives in a different place, like a different Excel file, a report or something. And rarely do utilities kind of have all of those data pulled together and kind of a comprehensive potential wealth of information that we're not necessarily utilizing. We have our models. And so we would love to have said, we mostly have these empirical models that kind of come from these academic studies and are in all of these published papers. And it means that our modeling tools are kind of all over the place. So we have this software from the 90s where you kind of click through and create your treatment train one step at a time. The EPA has recently been releasing a lot of our Shiny apps, which is great for kind of the transparency of the code, but it doesn't change the fact that the apps are kind of doing only one thing with one water. And then we have the fancy spreadsheet class of things, which is pretty black boxy because they are kind of putting all of that behind a wall. And all of these tools work, but they don't give all the capability for modeling a complete water. And it's just a lot of kind of manual data entry. So when we were developing Tidywater, we had kind of these three primary goals, the most critical being the accessibility. We wanted it to be a free or low cost solution. We wanted it to be easy to use, easy to kind of modify. And then we are already dealing with all of this messy data that we're pulling in all these different Excel spreadsheets, which is why we started using R in the first place. And so we thought it'd be really nice to just directly apply our models to that. And kind of similarly, when we're doing our analysis on the data already, it would be great to just do that same analysis with our models. We also wanted it to be modular because of how variable the treatment processes could be, and because our modeling goals are kind of different each time. And because new models are kind of always being developed to kind of better understand the treatment processes, new contaminants, things like that, and we want to be able to capture better models as they come into being. We also care a lot about scalability, primarily if you've heard that phrase that all models are bad, some models are useful. That is so true in our field. We have a lot of not accurate models. And so when I use that software from the 90s and I plug in everything and I get one number for finished water quality, that's not that valuable. Whereas if I can run a lot of scenarios, I can kind of do a sensitivity analysis, I can get relative numbers. Those are a lot more informative and can answer those kind of initial questions a lot better. So I love R, and I felt like R was absolutely perfect for this project because of the fact that R is kind of centered around data, right? And we use tidyverse for almost everything we do. And that kind of workflow of how it goes through the data aligns so well with how we need to use our data and analyze it and come up with answers. And having, tidyverse and all these other open source packages, all of this documentation that already got us, 80, 90% of the way there, really let us see how we could slot our models into that framework as just another step in the process. And so it meant we could kind of have a vision for what the package needed to be before we even started writing it. And then just this accessibility. We've had a lot of success teaching people who've only ever used Excel to use R, especially via RStudio. And then we've also had a lot of success building our own Shiny apps while knowing very little about how to write good code, but apps that are definitely good enough that non-R users can access things. But as I mentioned, good code is a challenge. And when we kind of came up with this project that we really wanted to have these models, we had to weight kind of our expertise in the treatment models compared to the programming expertise that could help you write a really good package. And one of our issues is we have all of these models and algorithms that are documented in not very helpful ways. I have one example, one here that's probably one of the most extensive. And then there's a lot of kind of detail and nuances in knowing which models apply in which situation. And so we couldn't write like a requirements document for this project any faster than we could just write the actual R code. And so then we said, okay, we want people with treatment experience. We want them to be at least pretty good at R, or as good as we can. And we came up with, 3 people on our whole team. And so we kind of had to accept that sometimes we were writing solutions that weren't maybe the perfect coding practices, weren't, the most efficient computationally, but they worked and we were able to do them, and it was relatively easy. But we really had to kind of transition our mindset because our team was used to writing kind of individual scripts for individual projects. And so when we were suddenly writing a package that had to be reused over and over, our processes didn't quite work. And so we used to use code reviews as kind of, we would do one final code review at the end to kind of check somebody's technical process. You catch some things in the code, but it's just your general QC. And so it meant that when we started working on the package, we would have these massive pull requests. Code review would take hours and hours, so they would just sit on merge for weeks at a time. Kind of similarly, like we knew that we had to write tests and we knew that it was important, but we're like, well, we'll just wait until the package is done and then we'll write all the tests, which meant that when we first wrote it, it was an absolute nightmare. And then our team wasn't trained in how to update those tests. And so you always submit a pull request that fails CI, and then you're trying to figure out what's going on. And then just kind of in general, we weren't used to having to functionalize our code, right? It's really easy in R to kind of just get in this scripting mindset, which is so great for data analysis, but it doesn't translate as well to actually making the package. And so we had to learn a lot about how to kind of break things apart and think about things logically. Um, I kind of mentioned the need for our quicker pull requests. And so early on, we had a project where it was just a really complex model and we desperately needed like Tidywater to be functional before it was really done. And that was great for the development of the package because we would talk about theoretically how we thought all these functions would fit together, try to implement it for a project and say, actually, none of that works. We need it to be set up like this instead. It was really hard on the project though, because we didn't have any stable version of the package. And so I would have one branch on my computer, my teammate would have a different branch. We would both be trying to run the project code and have it break in different ways. In hindsight, I wish that we had just tagged more versions of the package and then been really deliberate about updating the project code. But that's kind of, we learned our lesson with that project, but I still think the package was better for it. Kind of changing gears, it was really important to us to make this tool open source. There's not really kind of an existing tool that standardizes everything in our industry, and there's certainly not something that's open source, even though all of these models are kind of published. So the kind of roadmap that we ended up with is this mechanism for, okay, you work for a company, they have to make money, so you have to convince them that there's a business case for open source. So we started with thinking about the different stakeholders throughout the company and what we thought their concerns would be. And so for us, we knew that intellectual property would be a concern, and we knew there would be concern about kind of giving things away to our competitors and losing our edge. And so then we really started documenting in detail the reasoning behind open source for us. And so we wanted to address those concerns, but we also wanted to highlight this longer term vision. Instead of just saying, don't be worried, we wanted to say, be excited. And so for us, we found there are some key phrases that people were really excited about, things like thought leadership, collaboration. That would get people talking about it, get people thinking about this in the bigger picture. The other thing that I would say is I kind of had this private vision for the project of, oh, soon it's going to be taught in classes and everyone's going to be able to use it and people are going to understand these models. But that felt like really ambitious and a little bit embarrassing to tell people like I have these lofty goals for this package. But when I actually communicated those and when that became kind of part of our messaging of look at the potential of what this can become if we make it open source, that's a great way to get people excited about it and people on board with this vision. And so then kind of our final step was being really clear in all of these communications. So to kind of show you the example, this or some permutation of this slide was what we used in all of these different meetings with different groups to explain why open source was really critical. And so for us, we said, you have to kind of change your thinking. This is the way that things are currently done, and we're not trying to just add to that. We're trying to do something completely different. So I don't think this example works for everybody, but I think, being really intentional, having a strategy and knowing what your communication points are is really key. So we got people on board with open source and we kind of thought, great, we're done here. And then we ran into kind of more hiccups in the approval process than I think we were anticipating. And so on the left side is the things that I really thought we were going to be convincing people of, because it took a long time to build this package. And that means, a ton of overhead for a company where normally our time is supposed to be billable. And so I thought, we're going to have to convince them that's valuable. Thought we'd have to convince them of open source. I really thought someone would push back against it being an R package because they would say, most of us don't know R. It needs to be an application. We need to be able to use it. But actually, because we knew those would be concerns, we were so communicative about that. We told people those things and people were really on board. They were excited. The actual challenge was finding the correct process. So our company doesn't do very much open source. We don't do very much code. We certainly don't do a lot of, software libraries. And the people who do write the code are the people in kind of our software groups, not in the drinking water group that I'm in. And so we went through and we started saying like, okay, are you on board with this? And someone would say, yeah, I think it's a great idea, but I can't sign off on it. And we would say, okay, who signs off on it? And they would say, I don't know. And I think that's not unique to our company. That's what happens when you're trying to do something new, especially in an industry like ours, which is going to be more risk averse because safety is so critical. Kind of another thing along those lines is that we felt really confident in our expertise, but we weren't prepared to communicate that to others. Like, we know what we're doing. And so they said, we have a software team and you're not on the software team. Why are you doing this? So we had to be a little bit more communicative of, we've done our research, we're doing our due diligence, and we're working with those teams to make sure we're doing things right. And kind of the last thing, people were on board with open source, but then we couldn't get alignment initially on the type of open source license. So for us, it was really important to use a permissive license like the MIT license, which allows people to basically take the code and do whatever they want with it. But kind of the predominant mindset when we were talking with others in the company was that we should be using a copyleft license, such as GPL3, because that way, if our competitors took our code and adapted it, they would have to publish it and we would have access to it. And that totally makes sense from a consulting perspective, but it didn't make sense for our specific project because we didn't want any barriers at all to adaptation. Like, our number one goal is just that we want people using this package. So we kind of hit those hiccups, but then we've gotten motion recently, and I'm convinced this will be published. We'll get through all the approvals. We just kind of had to figure out what that process was. And so one thing was we did kind of end up working our way pretty far up the org chart, and it ended up going up to the CTO. And in hindsight, I think we could have done that sooner because she could make that call of, okay, these are who the decision makers needs to be. This is what we should do for the process. Also, kind of having other teams involved in the documentation of these processes and these decisions really helped clarify things. And in the example of the permissive versus the copyleft licenses, we found that once another team started writing down the logic behind software licensing, we actually completely agreed with them, and they agreed with us that a permissive license was a great use case for this and copyleft was good for other things. And so we thought that we didn't have alignment, and then as soon as things were actually documented out, everyone was on the same page and we could feel a lot better about that decision. And kind of lastly, we have our software team, we have our drinking water team, but there's a data team at our company that works a lot with both of those teams. And so using that team to kind of help communicate between the two groups and make sure that we understand needs and drivers and everything like that was really valuable. And in hindsight, we should have kind of pulled that resource in a lot sooner. So I wanted to kind of summarize the lessons learned that I've been talking about from the development perspective. More version numbers. I will be using a lot more version numbers as we continue with the package. Speeding up code reviews. I think a lot of data science people aren't used to this. Like, if you're not writing code, you're not used to like, okay, quick iterations, get things pushed out. And similarly, like being decisive about when to take shortcuts. And so if everything is solvers, that's fine because at least it's done. On the approval side of things, I think it's really critical to have a vision and be ready to communicate it. And it's okay to be a little bit pushy as long as you are kind of trying to do the right thing, trying to go through the right process. And then once you find your allies who understand what you're doing, use them. But at the end of the day, there's always those like unknown unknowns, right? And so you have to accept there's going to be little hiccups and you're going to be able to kind of persevere through it. So at the end of the day, even though we ran into some things, some problems, I'm really excited about being part of this sort of larger goal that we're seeing with R and people being able to access and utilize data and see the value there of open source, just kind of making all of these tools more collaborative and accessible. And I'm excited that we can be, one little piece of the puzzle and work toward kind of improved public health and, better efficiency and affordability in our drinking water systems. Thank you.